Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. We have finished doing an update of our game to 3D. There is one issue that we have to address that people brought up who are porting to other platforms. One of the things that, of course, is true now that we actually do use the 3D card. If you have been following along, we did an upgrade that allows us to use like a full 3D pipeline with Z-buffer and everything instead of doing software rendering or very light OpenGL like we were before. I kind of decided to go a little bit more real 3D with it. It just felt like the right thing to do based on what I wanted to have happening. So we did that upgrade, and it went actually very smoothly. However, one of the things that we did try to do last week was to transition from any sort of legacy OpenGL, which is what we had written it in originally, just to show kind of the simple version. We now are up to sort of modern, fairly modern usage of OpenGL where we're using shaders and all that sort of stuff. So at this point, we turned off non-core compatibility, and we have the driver issue errors if it can anytime that we do something that's outside of the core profile of OpenGL. OpenGL, of course, is a very old API, and it's been updated many, many times. And one of the things that they do during those updates is they allow driver manufacturers to support any old versions of the API that they want. Now, they don't have to, but they can. And so what happens with OpenGL when you open it is you're able to specify to the driver whether you want the driver to give you access to legacy features or whether you would like it to give you errors when you use them. Now, the driver is under no obligation to actually support those legacy features, but a lot of drivers do support the legacy features, which what that means is typically on OpenGL, you can get away with using some pretty old stuff, and the driver will just work. Now, what we want to do was move away from all that because it just helps to turn on core compatibility to ensure that you're using only the modern calls to the API, basically just to reduce the amount of variability that you've got in terms of being able to port to different platforms, run on different graphics cards. If you've got a really wide support surface there where you're calling stuff from that was designed in 1995 and stuff that was designed in 2014, that's a pretty big spread for drivers to test and to get working. And so you kind of want to stay pretty narrow and try to reduce your API usage down to the things which are only absolutely necessary for you to use. And so that's what we did. Now, one of the downsides of that is it does mean that any problems on this graphics card that don't get reported as errors because the AMD driver just doesn't have a problem with them, if they are not in the core profile, we may just not know, right? Because we don't really have any good foolproof way. There's no OpenGL lint program really that will go through and check for those old calls, or maybe there is and I don't know about it, but point being we don't have one at the moment. So all we know is what the driver reports as errors. But that doesn't mean that some other driver that's more vigilant or vigilant about a different set of things couldn't report errors about things we're doing that aren't in the core profile, but that the AMD driver just doesn't notice aren't in the core profile because no one added error checking for them in the AMD driver. And so we do have one place that other folks, when they're reporting to other systems, because we've got a bunch of people use the Handmade Hero code base and they port to other things. They port to Linux, they port to Mac. They do their own projects on it, whatever. So typically I do get feedback from people when there is something that another platform can catch. Either LLVM's compiler catches something, and maybe it's not even an error. It could just be a compatibility difference, for example. But you know, things that get caught from different compilers, different APIs, different platforms, whatever. One place we are still using something that I guess got deprecated in the core profile, and that is extension enumeration. You're no longer supposed to do extension enumeration via the GL getString call. You're supposed to get an indexed extension string, and we can take a look at that today. So I'd like to just do that really quickly before we get started. Mostly I'll just be blowing my nose all day, but in between blowing my nose, what I'd like to do is fix that, because that just helps people who are running Handmade Hero code bases elsewhere to stay up to date and not have to worry too much. So I'm going to go ahead and jump over there to the Handmade Hero GitHub, where we can take a look at that. So here's our current Handmade Hero GitHub. You can kind of see we've got some stuff mentioned in here. We've got this GL getString, GL extensions fails with GL invalid in them. That's the one that I'm talking about right here. So I'm going to jump over here. And you can see here, basically it's just the case that this is how we were checking for extensions before. And that check, that GL getString, is just not supported anymore. This is the explanation right here, actually. These other folks who commented, they are actually listing the correct way to do it as well. They basically just upgraded the API from returning the extensions in one big, huge clump to being able to get individual extensions by asking how many extensions there are and then asking for each extension in turn, right? So it's pretty similar. There's not a lot of difference here. It'll be very easy for us to support. So I just like to support that because, again, then these folks here who may be compiling on different platforms won't have to worry about this compatibility problem. Because I think right now we're pretty clean. People can compile all over the place and we just work. And it's worth keeping that going, because it's not a whole lot of work for us. After we do that, the rest of the day we're going to spend looking at additional features in the renderer that we're going to need just to replace some features that we had and that we don't have anymore, such as the alpha fading of things above the player or stuff like that. I want to go ahead and show you how to do some of those things. Now that we're in a modern OpenGL context and we already have shaders, I'm just going to kind of give you some examples of how you can leverage that sort of shader architecture to do some of the effects that we were doing before in perhaps different ways and things like this. So we'll just start playing with that, and that this weekend will mostly be about how to do kind of special effects, if you will, inside the shaders that are things that we might want to do. We've already done one of them, which is the fudging the z value so that we get different occlusion than you would expect. And so really what we're going to be doing is just looking at some more techniques that are similar to that. All right. So let's go ahead. Today is day 374. Let's go ahead and just quickly address that GL strings issue. So that's, again, just going to be something that happens in the extension enumeration. So if we take a look inside our OpenGL layer, we've got that GL getString call. That's the only place that we're going to be calling GL getString. You can kind of see it's this part where we just try to get some information for the driver. Now, as far as I know, there's nothing wrong with calling GL getString for GL vendor, GL renderer, and GL version. I don't think, anyway. And I didn't see anyone report that, so I'm assuming that it's still the correct way to get those particular things. Oops, why did I delete that? I meant to, yeah. There we go. So I'm assuming, since you'll notice here, they're only talking about this particular way of calling GL getString, not GL getString as a whole. So I'm assuming that all of these can actually stay, and it's really just this that's the problem. And what's going to happen here is basically we were previously parsing it into individual strings ourselves, and so what's now happening is we should be able to just use GL get integer v and GL getString I to basically get those out one by one so that we can actually not do the parsing anymore either, which is presumably good. So, that's pretty much a win for us as far as I can tell anyway, so it should be fine. The only question is which of those functions are supported and which have to be queried. So the problem, I suppose, since we're always asking for a GL 3.0 context now, I don't think we could really run without one. We can probably remove anything that was previously sort of doing stuff that was checking that we can pretty much remove any paths that were necessary only on things that were before OpenGL 3.x, because we're just not going to probably be able to run on those anymore, right? Because any platform that's before OpenGL 3.x probably won't have the shader support that we need in order to run the game. And so we're just going to have to acquire an OpenGL 3.x context or OpenGL ES. I think that's 2.0 maybe. I don't really know whether it's 2.0 or 3.0 OpenGL ES levels. But basically you need to be sort of at least a 10-year-old hardware. You can't be 20-year-old hardware and run this game anymore, which doesn't seem like a bad idea since nobody's doing that. So, all right, if we come through here, you can see this result.extensions equals GL getString extensions. What we need to do is sort of stop having this, like that kind of needs to go away. And I don't know if anyone was really looking at that besides us, so I think it's fine. So we can pretty much just not worry about that part anymore. So what we really need to do here is get an extension count, right? We need to find out how many extensions we actually have. And again, that was a GL get integer v call, just a generic call to the GL like give me a number command, and we're going to pass GL extension count, I believe is what there's, or sorry, num extensions, right? And so we're going to need to define that because that's a new enum, so we're going to have to grab that out of the core arb. But we're using existing function. I don't believe GL get integer v is anything we need to query because that's a function that existed in core OpenGL. It's just the enum we're passing to it that has changed. So in theory, oops, as I accidentally hit the page up key, in theory now we can just ask for the extension count, and then we can just go through the extension index here. Now, GL-getInteger-v, I think, requires us to pass the pointer where it's returned. So although this would be handy, I think that's not actually the phrasing of it. It actually looks like this, I believe. And this is probably a CGL int, or whatever, sorry, a GL int. And I don't know, but we'll double check in the docs. So once we get that, we're going to have to iterate over it with the extension index. We're going to have to go through all of the ones that it says that it has, exactly as you would expect in our own code. Nothing particularly weird going on here. So there's, the loop that we do. And then in here, when we're doing our strings are equal bit, and we're passing this like count at blah, 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 we don't really need to do that particularly anymore because I think we just get the string now. So let's take a look at getStringI and just verify because that's a new call for us, and we're probably going to have to query it. So we're going to have to look at the spec for that, but presumably it's very straightforward. Let's take a look. So here it is. You can see we passed the enum, which is the name, and the index, which is which one of them we want. And we could just switch to using this entirely, as you can see. So vendor, renderer version, shading language version. We could ask for all of those in GL-getStringI, and then 0 would presumably be what we would pass for all of those, and the only one that would do more of them would be 1, 2, 3, 4 in terms of the extensions. The rest of these are only one thing, right? So here we've got we're expecting to get a string pointer back, right? What's interesting about this is it's passing back an unsigned byte. Which doesn't make a whole lot of sense to me, to be honest, because I guess I don't know why you would necessarily that's not a char star, really, even though this technically is a char star. So I guess that's just maybe to indicate that it maybe could be UTF-8 or something. I don't really know. They don't really say here, as far as I can tell. So yeah, I'm not sure. But either way, it doesn't really matter. As long as we can do something relatively reasonable here, we should be okay. All right, so we're doing our getStrings here. Don't look like they need to change. Here we need our getStringI, and that's going to have to take the string index, and then it's going to have to take this extensions, the specific extensions. Why can I not? Well, doesn't matter. I can just type it in. So this will give me an extension, and it'll enumerate over each extension. And we can just say extension name here is going to come back to us. We don't need any of this parsing now. So really all we have to do, I don't know why we would need if0 here, because in theory, I guess that was just the end of the parsing or something like this. So all of this stuff can go away. And pretty much all we need to do is, oh, well, you know what? This if0 was probably just so we could make everything be an else if. A little bit cleverer than we probably need to be. But anyway, in theory now we can just do this, right? In theory now we can just do a regular string compare. We don't need a counted string compare. And we can look for our extensions this way. Now, I don't think either of these two, yeah, like I said, is defined. So we need both of those, right? And we could still preserve this path. I don't really know if we want to. But we could just say that you don't get any extensions if those aren't, if you're on an old platform. So we could still do this, but it's really kind of not necessary to do this to a certain extent because the game wouldn't really be able to run on hardware that was so old that it didn't support OpenGL3. Because that's just really, really old at this point, right? It's like a decade old or something like that. So, we'll put this in here nominally, but it doesn't really need to be there. And so then all we need to do is actually have that function. So we're going to have to grab that again out of the core arb. So we'll just go ahead and grab that. Here's the H file. GL extensions is one of them, and num extensions is the other. Although it didn't seem to complain about GL num extensions, did we put that one in here? No, we didn't. I don't know why it didn't complain about that. Oops, I need the whole thing. That's weird. Oh, it is num extensions. Never mind. That makes perfect sense because GL extensions was still there, right? I was like, what? I was like, why is it only complaining once, right? Because extensions used to just get the whole thing. So it's all good. All right, so GL num extensions is the only one we need there. And then getStringI is the other piece of the puzzle. So if I go ahead and grab that out, I can go ahead and put that in the Win32 side of things. Here's all of the stuff that we've been adding, and I'll go ahead and add that here. So let's get rid of that. We've got a const glue byte, an API, GL getString. Here it is. I'm going to go ahead and add type to that and make it a type def. There we go. And then again, same thing that we were doing before, where we just do OpenGL global function. GL get string I. And I probably should change all of these as well. Like, we probably should just go do that just now that we have a specific way that we're doing that. Here we are. And so in theory now, we're actually properly compiling with the right way of getting the extensions. I don't know if that works or not, because obviously all we did was kind of throw it in there. So I'm going to go ahead and step through it. I want to watch and make sure that we're still checking for these extensions correctly and that there isn't something wonky going on. All right, so that's not particularly helpful right there, right? That didn't appear to work. So why not? So I guess the problem here is that we get the info before we may have gotten GL getString. So I think we probably need to reorganize the order in which we do those. Probably need to make sure that these guys, or at least the getString one, happens first. All right. There we go. And so these will come back one at a time. And you can kind of see them coming back here, right? Each extension comes back one at a time. Now, in theory, we should be able to get all of these, I think. And so I'm just going to double check that we actually do. What's going on here? Oh, wow. Slow morning, huh? Gotta love that. All right, anyway, back to our show. So after we get all this stuff out and we take a look at the result here, we should see that we did get those extensions, and we did, so that's good. I just want to make sure that we did because I know they should be there. And so I want to make sure that we were still getting the strings back in a way that properly matched. So that looks pretty good to me. So we'll consider that resolved at the moment. We can sort of punt it back to the folks who are testing on the other platforms and see if it works, and just let them know. So this should be fixed as of day 374. Please let me know if it isn't. So hopefully that should basically just comply with the way that they needed it to happen on their platforms. And that's more compliant for us as well. Not that it matters on this particular machine, but it would matter on other machines potentially that we're using different drivers. So hopefully that's all good to go. All right. So that brings us back to where we were before. So here is our current state of the rendering. And you can see that everything's working pretty nicely. This is what we expect the game screen to look like roughly. And again, we don't have the art in there yet, so we're going to put in the art probably in a week or two. We'll put that in once we've sort of got the rest of the rendering stuff done. All of this looks right. The sprites are standing up properly. Our alpha levels are not as good as they could be because we're only using alpha to coverage right now, and we're not using a secondary pass for things like shadows. We could do that, and we may want to. And so we need to think about that as a possible thing to do. We'll talk about that in a second. Also, I think we have some work to do on this stuff, just cleaning up the way that the clipping, like I think the clipping regions aren't working at the moment, right? Yeah, you can see here, like this is still broken. So we need to make sure our clipping regions are transforming properly. At the moment, they definitely aren't doing that. So that's some stuff that we have to do there. And finally, we've got to redo sort of those graphics effects. So we've got a bunch of things just to finish up the rendering port. Now that all the rendering is working properly, we still have more things we might want to do to get ourselves back to the feature parity that we should be at compared to the old way of doing things. And just with a bunch more goodness. Like now we've got a Z buffer to play with and a lot of other things that might be nice. Okay. really want medical science to come up with a way of stopping, like, allergies. It'll be so nice. I know they're working on it, but I also know they haven't quite gotten there yet. All right, so the first thing that we need to do before we talk about any of this is we just need to put ourselves in a position where we see the problems that I'm talking about. Now, obviously, we could go work on the debug system, but I'm kind of more interested right today in terms of looking at some of those shader things. So I just want to do that first, and then we'll look at the debug, cleaning up the debug tomorrow, perhaps, assuming we finish this stuff. So what I want to do here is when we're building our sort of little bogus test world here, just that we've been using to play around with, we've got this sort of thing where we're doing rooms, and right now we're not doing any rooms that are stacked on top of each other. And what I want to do today is look at rooms that are stacked on top of each other. So I want to switch this room generation over to actually do exactly that. So in here, right, where we've kind of got this thing where we've got our door direction, I want to just make it so the door direction is like always going to be up, right? So basically, there's always going to be rooms essentially above and below us, I think is what I tried to do anyway. Although that doesn't really look quite right, because although those two rooms are on top of each other, it looks like it's still doing rooms to the side. So maybe that's not quite enough. Oh, whoops, what did I do? Oh, it was only doing 2. That's random choice. That's not what we want at all. I want door direction equals. This is the one I actually wanted. That was my bad there. Sorry about that. All right. So now, in theory, I don't actually know if this is true or not, like I was saying. Let me see. I always forget how to use this. How do I zoom? Does anyone remember how to zoom? What's going on here? What is going on here? I forget what I bound the stuff that we were using to. I know what rotate is, but I never remember what zoom is. What is zoom? No? Okay. So it's Alt and middle mouse button is supposed to zoom. All right. Here we go. All right. So that's not actually zooming. So we've got some, and plus there's something weird going on here. Yeah, so our zoom does not seem to be working, but I don't actually know why. And we're kind of in the middle. I don't know exactly what's going on here. This is a bit wonky. So I think we've got some problems with our debug camera placement. This does not look, in case anyone was unclear on that, that does not look at all like a proper place to put this. So I want to make sure that, I want to see what's going on there. I don't really know what's going on there, so we'll take a look. All right. So here we go with our door direction being 3. I guess door up or door down. I don't know exactly what this. We probably at some point need to actually make this test world code start to build out real world code, because it just takes a while to deal with the sort of how ridiculously hacky this test world creation stuff was. It was always just there so we'd have something to work with, but we kind of always need to actually have something there. It's difficult to funge it into the way that I need it to work for any given time. What I'm going to do here, just to get started, is I'm going to make it so that it only generates 1. And I want to see what's going on here. So there's generating just a single room, right? And so we're getting some weirdness here, right? Like, I don't know what's going on there. Like, we're getting some weird. It feels like the world stuff is getting generated. Like, when I right-click to switch to debug mode, I'm getting an error on that. So I think we just still have some problems with what is considered our like where our world region is actually doing its thing. So I think we still got some problems in there. Like, that's as soon as I switch to the debug camera. And the debug camera really shouldn't have much to do with it, but if you remember, it still kind of does, because we use a camera projected place for where we're doing our world simulation, which is probably not particularly right anymore, especially when you consider that we have debug camera and stuff like that in there. We probably need something a little more robust for a couple of reasons. One is that right now, when we do, when we do an update in render world, I think we do an unproject actually. So you can see we do get camera rectangular target with the render group. I think that just goes through whatever the last project value was, which means that the debug camera would affect where you were simulating, which we don't actually want. We want that to always be from the real camera, right? So there's some wonkiness there that we need to address, and so probably that has to get fixed as well. At the moment, that definitely seems a bit weird. I want to see what we're getting for the recanonicalized coordinate situation here. I want to see what's getting passed. What's the okay? So this is just a completely invalid offset thing that's coming through here. So that's obviously wrong. And again, I think that's because our unproject call is not quite correct yet, or we are passing the unproject call something that can't really work properly. So if we take a look at the world, yeah, so there's the world camera rect coming back during debug, and you can see that that's just not, yeah, even remotely reasonable. Let's just double check what's going on there. It may be that that's what should happen, because maybe the debug camera is messed up or something like this, but it might also just be that this code is bonked. All right, so yeah, this is nuts. I don't know why this Z is passing an 8 here. That's some hard-coded nonsense from the old days, so we probably want to just clean that out. Let's go ahead and take a look at what's going on in here. World distance from camera being 8. Yeah, who knows why that was the case. And you can see here that's going to pass that in. So let's just see what happens. We're passing in this, this to the unproject. So we're going to project forward that probe Z. You can see that that gave us a negative 0.2. So there we go, our clip Z. The probe ZW came out as actually exactly 0. So that's a problem, right? The probe ZW in this case literally coming out to exactly 0. I guess that's because 8 is right on like where the camera is or something. But that doesn't make any sense. That shouldn't be true. I don't know exactly how that would be possible. Because if this is something that's supposed to go... Oh, you know what, though? Yeah, see, this is just kind of broken. So we forgot to do, when we did our unproject, this world distance from camera Z actually needs to be, if we're going through the full projection here, this forward projection, this actually needs to correlate to that in a real way, meaning it can't be affected by the position of the camera, and it's got to be along the camera's Z-axis, right? Otherwise, this isn't going to work. So actually, this code is not correct. First of all, it isn't a positional coordinate, so this has to be 0, right, in order to not take up the position part. And second, this has to actually point down the Z-axis. If it doesn't point down the Z-axis, if the Z-axis is pointing a different direction, that is not going to work. So that was just kind of sloppy on my part, and that's something we're going to have to fix. This is not super related to the problem we were seeing before. This is just, again, we just finished all this code, and we have not had a chance to really debug it and test a lot of it yet. So, you know, there's going to be some growing pains in here. All right, so first of all, what I'm trying to do here is I'm trying to get a Z value to figure out where in clip space this far away from the camera in world distance we would be. And so I'm passing that in and doing a forward transform on it. The thing is right here, what I need to know is I need to know what this would be if it were that far along the negative Z-axis, I guess, in this case, right? So I need to get that negative Z-axis out of the camera transform, and furthermore, I don't want it to be positional. So one of the things you remember about homogeneous coordinates, x, y, z, w, the 1 here is what allows it to pick up the position. If I set this to 0, it will not pick up the position, right? Because all that w being 1 is what multiplied each element in the matrix that was a positional element in the matrix. By setting it to 0, I will force it to be always relative to the camera's location, which is what I want in this case, right? Because it's never going to move. just to underscore what that is for folks who are maybe coming to these things who aren't super familiar with them, if I just draw it out really quickly, what happens in matrix land, we have the upper 3 by 3. That's the rotational components, right? The x, y, and z axes. And then we have the position here, and then a 0, 0, 0, 1 at the bottom, right? This is what the camera transform currently looks like. And again, these are inverted since the camera transform, so the x is here, the y is here, and the z is here. They're rows, not columns, because it's a camera transform. And this position is the inverse position multiplied by the r. Remember, this is the camera version. So instead of just being the location of the camera, it's actually the negative rotated position of the camera. And that was because that's what needs to happen in this matrix in order to center things around the camera after they've been rotated by r, which is how they will come through, right? And we're multiplying by an x, y, z, usually a 1 here, right? That's going to multiply this p. Because remember, the x, y, and z, they're multiplying these in here, right? Because the x multiplies these positions, the y multiplies these positions, and the z multiplies these positions. But that 1 multiplies these, right? And so if we change that to a 0, this is now irrelevant. It does not matter what's in there. And that's what I want in this case, right? So I want there to be a 0 there because I don't want it to have any effect. So the other thing I need to do is I need to get the z-axis. And so in order to get the z-axis out of here, I need to extract that camera z. Now remember, the camera z is in the wrong place compared to an object transform. Normally it would be the columns, right? Column x, column y, column z for the axes of the camera. This is a camera transform, so it's meant to invert the placement of the camera. So the camera z-axis is actually going to be the row here. It's going to be z. And again, I want to get that out. So if I take a look at my math routines, I don't know that we have a get column, get row call. We might. It looks like we do. And so all I want to do here is I want to get that row out so I can use that row as the displacement that I'm using for my world distance from camera z. Now that get row call is going to want to get not the 0s, not the first, but the second row, right? Or row 2. It's the third row. And I want to get that out of the camera transform matrix. So if I go through last proj forward, that's where that's going to come from, right? So once I get that out, now I'm good to go. But the problem is we have to think about the directionality here. Now remember, our camera is z pointed backwards. So if I was to do it exactly like this, we would be the world distance from camera z behind the camera. So I want to be in front of the camera because, remember, the z-axis is pointed back towards the viewer, and I want to go away from the viewer. So that's going to have to look like this. Now let's take a look at, oops. There we go. In this case, right, I'm going to have to change to doing this because since we're now moving in a real direction, we're not just x0, y0, z is some value. We're now an actual vector. We're along whatever this direction is, right? So I have to initialize myself with a vector 3 and then the 0 for the last coordinate. OK, so now I'm expecting, although I don't actually know, hold on a second. Now I'm expecting when we come through here to get a more reasonable result here. This I still think we need to get rid of because we need to actually know how far away our target is. That's a separate situation, so we'll take a look at that in a minute. But just for the time being, let's assume 8 is always a reasonable value to pass because it should be 8 away from the camera. We should not get an invalid result from this at all. So let's just make sure that we're on the right track there. So here's our probe z now. Let's take a look at what the probe z ends up being. It should be a regular vector. Now again, the camera is actually pointed directly down, so it actually is the correct z here now, so that's actually fine. But with this 0 in here now, we're going to get a real value, so we won't have a z equals 0. And our probe z value should now have a w coordinate that is reasonable, and it does, like you can see that right there. And so let's take a look at our clip z. Our clip z is 1. That's still weird to me. That feels like I still have some bug in here. The reason that I think I still have some bug in here is just because a clip z of 1 would be right at the near clip plane, right? I'm sorry, right at the far clip plane, which doesn't make any sense here to me, really. So I think we're still a little bit wrong-headed in our thinking. That's just my assumption here. I don't actually know that that's true. but that seems like it to me. Right, and I'm not sure exactly why that would have been the case either, because that seems like a weird clipsy to have in this case. I'm going to step through this a little bit more, but that still feels a little wonky to me. I'm not super comfortable with that at all. You can see that we are getting a result out of here, so it's not mathematically degenerate like it was before, but I still don't think that's correct, because the clipsy value should have been something more reasonable. It should have been something more like in the range between -1 and 1. It should not have been at the extremum, because this is a very reasonable value of z to be placing. That should just be like in the milquetoast region of the clip space. And so I feel like there's still a little bit something wrong there. We're not broken like we were before, so that's a plus, but we're not right. And so you can see now at least we're not getting any of that crashing behavior, but it's definitely not, that's definitely not what we want to see. So let's just take a little bit more time to kind of get in there, because again, this is exactly what we want to be doing right now. We don't want to like go further down the path of working with these things before we've got them a little bit more under control. So I want to take a look at what's going on here with that and why that's happening. So let's think this through a little bit. I want to take a look at what our probe Z value is and what our camera is supposedly. So if you take a look at what we've got for our camera location, okay. I think I maybe misthought that. So since I am inverse transforming this, the z values that come through here, as I do the forward transform on them, I do want to place them back into the camera space on the way back out. No, but I think that should still be 0 going through. Well, anyway, I'm going to step through this a little more carefully. Hold on a second. Because I'm just not sure, and I want to look at the values and actually work them through properly to make sure I'm not missing. Because again, once you get to this point, there's just a lot of math involved in the transforms forwards and backwards, and you want to make sure that you're not doing anything stupid, right? All right. So here's the probe Z value. Actually, I guess I don't need to expand it. It's right here. And so that probe Z value is an 8, which means that the world distance from camera Z, I'm guessing that where's our transform here? So the camera Z being negative on Y slightly. Is this right? I feel like there should be no, I feel like it should be pointed directly down, but maybe that's not the case. Like, shouldn't this Z be directly down? I don't know why it's rotated at all. That's a little bit weird to me. But, you know, that's fine that it's slightly down. So the Z coordinate coming up, meaning in the 1 direction, is pointing back towards the viewer, in theory, right? So our probe Z value of 8 is actually, seems to me to be going in the wrong direction, right? It should have been world distance camera. This negative here, why was, it should have been picking up this camera Z value. So I don't quite understand what happened there. I want to verify, in fact, I guess I don't, because we have the camera axes already, I guess I don't need to do it this way. I guess the problem is this already has the projection baked into it. So I guess I don't want to get it out of this matrix. So I suppose I want to just use the group z-axis is part of the problem, right? I'm going to go ahead and get that row so I can look at it, but that row has built into it, yeah, okay, so that was dumb. That's the problem right there, or well, that's one of the problems right there. So getting the row, I was thinking of this as the camera matrix, but it's not. Last proj is actually already combined. It's the camera matrix plus the projection matrix, and I only wanted the camera z. So what I really want is that, because the other one is not the z-axis of the camera anymore, right? The last proj isn't. That's why we saved this value, was for this exact kind of thing. All right, so that is a more correct probe z. And that's what I expect to see. I wanted that value to appear negative, because that's what it should have been, and I was upset that it was positive. So that's why I was looking a little bit more deeply at that. You saw that I was uneasy about it. That what was making me concerned, because I'm like, my intuition tells me that this should be positive, because I mean, it should be negative, because again, positive's coming at the viewer. Why isn't it negative? Something's wrong, or I'm misunderstanding the math. And something was wrong. We were looking at the wrong, we were getting the wrong value for the camera z. Now that that's correct, let's take a look at the other parts here and see how they go. So let's see what our clip z is. So our clip z is still busted, so I'm still not quite there yet, right? I don't quite understand how we could get the same clip z in either case. I guess that's because the w coordinate coming out of there So I guess one of the problems that we do have here, and this is me, I guess, just continuing to have to make life a little more difficult for myself. Now that I think about it too, the problem is we won't get any z displacement either if I set this to 0. So that means, right, because if you take a look at how we're doing the projection, right, what's actually happening in the combined matrix is, you know, we've got some xy modification up here. It doesn't matter what these are. Actually, we don't care about these right now. But in our 0, right, we've got some stuff where right here and right here are two values which are both controlling the z range. And of course, this one is dependent on w being 1 coming in from the top, right? Because it's going to multiply that z offset. So our equation for z was affine, right? It requires, you know, something times z plus d, right? Because there's a c and a d here. And so I can't set this to 0 and still get a transform that produces the correct z range, which is the whole point of this exercise. So it does look like I need to actually go the whole 9 here, which actually isn't that bad. I just set this to 1 to do a full transform, and then all I have to do is actually just start at the camera's position and move by the z-axis, right? That does put me in the right place relative to the camera. So I suppose that is the more full way to do it, and I think now hopefully I get it. Yeah, there we go. I get a better clip C that's actually within range. Now that clip C still seems weird to me. That clip C seems way too high. And so I'm still not sure that I'm doing this correctly, and I want to keep digging in. You can see how many small bugs I had in here just from looking at this. So if I start at the camera's location and I move by this many units along the camera's z-axis, again, I'm going opposite it because I want to get away from the camera. I would expect this now to transform to a relatively small clip Z value. Right? I would not expect it to be high like that. I would expect it to be close to the middle of the range, or actually probably even close to the negative side of the range, because we're just not very far from the camera. 8 is not very far compared to the far clip plane. So I wouldn't expect it to be bunched up like that. The fact that it is bunched up like that suggests to me that I still got a problem, right? Or that I'm thinking through this situation incorrectly, right? So I'm not sure. I'm not sure why that would be the case, because this should be something close to the camera. It should be 8 away from the camera, like literally just move 8 away from the camera. But that doesn't appear to be what's happening with the clip Z. Now I'm going to kind of go through here and just see what we end up getting for results, because I'm not sure what we would end up getting here. Let's see. Those are pretty reasonable things to come out with in this particular case. So I guess it isn't quite that weird, but it's just It's just not exactly what I would expect. I feel like this is one where I want to actually work the math out directly and see what happens. Because I want to understand why I'm not getting that z value that's more in that range, and that just makes me think that something's busted here, right? Because that just doesn't seem like a reasonable z range value. So I would have expected this value, this probe zz, I would have expected that to come out differently. I'm also kind of interested, can I come through here? I want to see what's going on here. So we're calling this function, right? And so you can see our z and our w sort of operations coming through here. They look pretty straightforward, so I can't say that anything looks particularly odd here. We've got px times ae00, py times ae01. So we're kind of going along the rows, which is exactly what we would expect to see. Then we do the next one. We're one row down, down, down. That all looks totally right to me. So I don't know. I do not understand why that's doing what it's doing. What was going on there? Hold on just a hot second. Okay. For some reason, it looked like the p-value was all zeros there. I guess that was just because I'd stepped out or something. Let me come through there again. So here's that probe z. Interesting. So it's x, y, z, 1. So this is literally at the origin here, right, is what we're actually projecting from. And that's in world space. So the camera P must be exactly 8 away. Yeah, it is, which is funny. I guess that's why we were passing that hard-coded 8 there. So we're exactly at the target location, right? So passing 0, 0, 0, 1 down, okay, that's fair. But again, like if we just look at where the camera where the camera position is here, it just does not seem sane to me that we're getting that result out. Now let's take a look at what we have here. Although those values look really, this just looks really suspicious. Because I thought our far clip plane was like 1,000, right? All right, let's investigate. I am just a confused individual at this point. I want to go take a look at what's going on here when we actually build our perspective projection matrix. All right, so let's take a look. Here we are in the set camera transform call. And we're going to come through here and build our perspective projection matrix. Here we go. And so you can see here's our supposed near and far clip planes, right? It's 100 and 0.1. And so those are the two, nominal clip planes we just kind of hard code in here because we don't actually have any code right now that tries to set those. We don't deal with near and far clip planes hardly at all. So what are our D&E values, right? -1 and -0.2 are the two values that we're getting here. And we're sort of placing them in here, in here. Okay, so let me think that through. Does that make good sense to me? And we actually do our tests here. So we took a look to see whether or not the near and far clip planes, when pushed through here, produced values that we thought were correct. And let's see. So in our test 0 case, we get a negative 0.1, which is, I guess, what we would expect to see there, right? Well, actually, I should think about what we expect to see there first. And we get a z equals 100 there. Well, actually, these are not very good tests. These have to do their divide, so let's go ahead and actually make them do that. Mr. Mathy Poo. There we go. So we really want, in this case, when we do this transform, right, what I really want to do is I want to do a full transform here. Yeah. And then so that when we get the result out, we can do the divide and see what we actually get. Like, this is what we actually want to do, right? So in this case, or I guess I could do it this way. I don't know that we have a divide equals. There we go. Can we do this? Yes, we can. Okay. So in this case, we could now actually get the test code to do what I wanted it to do, which is, let's go through here and see, which is it should give us the actual, like the actual values divided by W, right? And these should both go, and after the divide, they should both be equal to the near and far clip planes, right? When we pass these in here, they should be equal to -1 and 1, respectively, right? Is what these are supposed to map to. So let's see. So this z maps to -1, which is exactly what I wanted it to do. And this one should map to 1, which is exactly what I wanted it to do. So it looks like we're OK here. Let me just run the program a little bit more, switch to the debug camera, and now go ahead and double check that. So here we are again, just again looking at these test xyz. That maps z to -1. That maps z to 1. All right, so these are correct, at least in terms of verifying that when you push the things through, that should be at the near and far clip planes, at least I believe. Things that are at the near and far clip planes, you get the right results out. Although, yeah, there's no positional elements here yet. So I feel like we can sort of fairly safely say that this is properly doing the z distance, right? So nothing unusual is happening here. It's all correct. Okay. So now the question is, why are we getting weird results, or at least is it just me thinking they're weird results, but they're not actually weird results? Why are we getting weird results in the case where we're trying to do the reverse projection? Let me actually verify that the two versions are correct of this, although I think that's not what we're looking at right now, so it doesn't matter. But yeah, these are all the identities, so that's good too. So that's, yeah, this is all pretty good. So this is the other thing here. So these also only happen, yeah, so so this is the part I was talking about before, so we probably want to clean this up before we follow the debugging anymore as well. So again, when we're using the debug camera, we don't update these, and the reason we don't update these is because anyone who uses those, right, for unprojection, wants, that's how we were doing like our sprites and stuff. We want those sprites to keep doing their projections as if they're from the camera wherever the camera was, right? What that means is our unproject call, which is also should be going from, should also be going from the actual camera location, because again, all of the simulation stuff should all be going from that camera location. is also going to use that. What that means is that when it does the unprojects, those unprojects should come from not from the debug, right? Not from the debug camera. So when I come down here for last proj, what I really need to do is that, we probably want to make these really explicit. This is game camera P, game camera X, game camera Y, game camera Z, game last proj. What I think we want to do is store both of those, right? We want to have like something like the render transform. I don't know. We've got too many of these at this point, but we could clean those up in a second. I kind of want to store these and say, look, here's the stuff. This is the P, the X, the Y, the Z, and the projection for these guys. And we want two of them. We want the game version and the debug version. And we want everyone who uses them to be knowing which one they're picking so that you don't get in a situation where you're using half of one and half the other, which is sort of what would have happened in that previous case. It's not good, right? So in all of these cases where we're pushing bitmaps and stuff like this, all of this stuff wants to go through the games version, right? So in all these cases, we want, like, what did I call it? I guess we want maybe game transform and debug transform, something like that. Right? So we want something more like this. And then in the unproject, what we probably want to do here is we probably want to specify which one of those we're using. So if you take a look at the group, you can see that what we're doing from this group here is we're getting sort of like, in these cases, we're getting the camera information out of it. What we could do is when we do our unproject, we could say, well, you can pass us the object transform, also pass us the render transform, right? So whatever the render transform is that you want to use. And that way we can sort of say, well, okay, now you can unproject from either. So if you're trying to do something like debug picking of an element, you can ask the unprojector to unproject from the debug camera, which is the one you're looking through. But if you're doing something where it's supposed to be like world simulation and you're trying to figure out what region the camera can see, that should still be going from the game camera. And that way you can do either or, right? So let's just go ahead and do it that way. I think that's a saner way to do this. At least it seems like it to me. Right? So now we get down here to the unproject call, and in this case, we know from this one anyway that we're pretty much always going to use the game xform. I don't know why that wouldn't really need this part of it at all. And so I feel like maybe the object transform part should be pulled out of here to the person who's actually using that. So this should probably be this, right? And this should always just return the world P. And then this object transform is just an additional piece that if you want to do that, you could. So I don't know who was unprojecting with that transform. Let's just find them. Looks like nobody in the interior was doing that, right? And so maybe then what we could do is just say, like, we'll deal with this in a second when we find out who was actually using that. Okay. So let's see. This goes away, and we don't need that. And then in here, when we're actually storing all this stuff, and we are storing like the proj, last proj, and that sort of thing, in push setup, I guess what I'm not sure is when we do push setup, why are these getting done in two different places? because last proj and the camera XYZ kind of want to get updated together, right? So I feel like this wants to be structured a little bit better. Let's ignore that for just 1 second. And I'm going to come back to that in a second here. So this is all, we don't really want to deal with that at the moment. Okay, so here we go. Let's take a look at this unproject call. So this one is really not right anyway. So I'm not sure how much we care about this stuff at all. Because this we have to do as a raycast now if we wanted to actually do that mouse picking. So I would just say this at the moment is not going to happen. So we don't care about that because we need to use a different path entirely for that. And so the only person we really care about is the debug people. They were passing default flat transform anyway, so that's fine. So what we could do here is say that these guys are just going to use the game XForm because they don't have a debug transform really. The debug UI always has just the main transform. It doesn't really have the concept of a separate debug view at all. All right. So finally, let's see. That just needs to take one of these. So really, I just now need to clean up this push setup stuff a little bit. So you can see what happens here when we do a push clip rect. Any of these guys, they all do setup pushes. And so I feel like what we really want to do there, I don't really know. I mean, just looking at this, right? And I look at the prod situation, you can see that the rectangle itself needs to get that information. I feel like what I want to do is back this out a little bit and say, okay, we're not going to store that in last proj because that's not really the person who knows what should be happening here, because whether or not it goes into the debug or the regular version is going to be the determiner of, and that's only known a little bit further outside. And nobody's going to, yeah, so I guess we need to know that because we need to push on whichever one is actually appropriate here. But I guess the thing is, this inverse projection situation is not really what we want to store, I guess, because no one should really be looking at that one in terms of when they're actually using stuff. So people need to store that ahead of time. So what we really want to do here is just pass the M4x4 that wants to get stored. And we can still make that be last proj, which will just be used sort of this way, right? And in here, I can put an M4x4 last proj as soon as I'm done with that. And we can talk about how that works in a second. So when I do a push clip rect, again, all that wants to do is modify the clip rect. So again, that can just pass whatever the last projection was. That's sufficient because it's not trying to change anything. And so then really the set camera transform is where things need to get a bit saucy. So what we want to do here is I want to actually build now a render transform. And I want to build this to have all the information in it. So xform.proj is actually the thing that we would be sending down as the projection matrix here. Although actually not quite right. It's actually, when we do the composite version, it's this guy right here. So we're really going to do like xform.proj. Like so. And now we get all the information there. We can also verify the way we were doing. When we do our push setup, again, we're just doing our xform.proj. And we're going to do the forward version. And if we look at what happens here, really, I probably want to just write this directly into the place it's going to go. So probably what I want to do is say, well, is it a debug or isn't it a debug, right? If it's a debug, then what I want to do is I want to overwrite the debug xform. And if it's not, then I want to overwrite the games transform. Oops. Right? And then when I write into this, I'm just saying like, oh, okay, I'm always going to write into something. So all of this stuff is always going to get written into. It's just a question of which one I'm writing into. And now I save them all. I always save both of them. So you can choose which one you're going to use depending on the circumstances, right? So that feels a lot better to me because now we're storing both paths, whichever one you updated you store, which feels a lot better, right? There we go. And so then we still want that last proj because, again, that's just what the renderer is going to use. So when we're pushing clip recs and stuff like that on, we always want those to be whatever the renderer is going to use. So we still want to save that last proj as a separate thing, but it's not actually used for anything other than the clip rec stuff anymore. All right. So I think that's all good. What's going on here? I'm not sure. So, OK, this is just that. Go. So we've got last proj, push setup, last proj, push setup. OK. So now I'm comfortable with that. I can just now say that we do have, oops. That we do actually have a last proj here. And so now, in theory, OK, and you can see we've already fixed one of the bugs we had, which is that this rectangle projection was changing with the debug camera, which we didn't want. And so now that's stable again, right, because it's always going through the game transform, so that's good as well. And so that's just a little bit cleaner, and that's all good. Now, again, we've kind of got a stack of bugs we're working through here now. So let's get back to what we were doing originally. Now that I know we're going through the correct stuff, I want to go back to taking a look at this unproject call, which I still think is busted. So I want to take a closer look at it. Here we go. And so now I just want to see what the transform looks like that we're starting with. So let's clear out our watch window and take a look. So here's a transform that we're starting with. I want to take a look at the render group as well. And looking at the render group here, I just want to see what the difference is between these two. So here's that debug transform, right? And so you can see this is not being transformed. This unproject is not transforming through the debug transform at all. And that's great because this is the thing that gets the simulation rectangle, so it should not be, right? And this is why you notice the reason that I went down that little bug fixing tangent was just because I noticed that it was a tilted camera. And I was like, the debug transform, when I first switch into the debug view, is directly down. So I was like expecting to see an identity in the upper 3x3 kind of a situation, which is exactly what I see now. The x, y, and z axes, these are 1, 1, 1, exactly what I would expect. These are not what I would have expected. And so I just wanted to make sure that I was, apples to oranges, apples and oranges and delicious tasting oranges and all those sorts of things. Anyway. So when I come through this unproject now, we are doing the regular game camera transform, though. And we're not mixing and matching, which is also good. So let's take a look, though, at the rest of this and see what's going on, because, like I said, I think it's still probably incorrect. And the reason that I think it's incorrect is I just don't love that value. It doesn't make a lot of sense to me why we would getting a value that's such a high value in clip coordinates. What I'm worried about, and maybe... basically, the thing that concerns me here is that it feels like that would be a correct value if it was negative, right? Because I believe the Z buffer is supposed to get larger as it gets further away. I mean, supposed to is not really mean anything because there is no definition of what Z buffer values have to be. It's just they have to get mapped between -1 and 1 somehow if you want to use a fixed point Z buffer, which is what we're using at the moment. So they have to get mapped between -1 and 1, but how they arrange themselves in that space is entirely up to you. It's whatever we put in the projection matrix for computing the Z value is how they'll come out. But we have a certain comparison function that we're using for the depth buffer, and I thought that the comparison we're using is that the z buffers should be less, they should be getting less and less as they get close to you, more and more as they get further away. So -1 I thought was right at the near clip plane. Now, what I want to do now is verify that that's actually true. Maybe that's not how it ended up, how we ended up mapping it, and I'm totally wrong. But I just want to verify, these assumptions, because again, there's so much involved in a 3D pipeline. It's easy to lose track of values here and there, and if you don't at any point take a look and actually test some things and verify that you got stuff right, it's easy to have crazy bugs in there that can stay a long time, and you just happen to be passing the right values around that make it so it doesn't actually become a problem, but we'll see. So yeah, I mean, here you go. You can see the depth function for passing is less than or equal to. And I believe that's the pass function. And we can, again, we'll double check that with the documentation. But what that would mean, assuming that I'm not mistaken, is less than or equal to, in this case, means you will draw if the z value is less than or equal to the value that's currently in the depth buffer. What that means is that the near clip plane should be -1, right? It should be the lowest possible value coming in there. Again, unless I'm misunderstanding those values and they get flipped around by OpenGL or something like this, but assuming that that's not true. So I want to figure out what's going on there, because it should not, that is not what I want to see happening, right? Okay, so we got to figure out why we're getting those results. I feel like what we should be seeing is that if we start at the camera P, which is what we've got here, and we walk backwards along the z-axis by world distance from camera, if world distance from camera, in fact, we can do this test exactly. If world distance from camera was exactly 0, or exactly the near clip plane value, what we should see is after the transform, we should get literally the near clip plane out. We should get -1 out. And if we walked the far clip plane distance away, we should get the other value. So let's just put those values in as tests to see what it is that we do get, because that's just a good example of like us figuring out a way to probe this, right? So what I can do here is just say like, oh, all right, when we do this unproject, let me just force it to call this in some circumstance here that's going to be handy for me. So if I come through in world mode where we're doing these unproject calls, where we do get camera rectangle target, right before that, let me just call it with exactly the values that I want here. Now, I guess pixels XY, we don't care what it is, really. It shouldn't be relevant because we're looking at only that first part where pixels XY isn't there. So I'll just pass 0 down, and that should be fine. In the render group, we know what that is, right? It's just we've got that pass into us. And so I'm going to take a look at doing the render group. Let's look at the debug transform first, I guess, because that's the easiest one to deal with without being saucy. And then I'm just going to pass, as the world distance from camera, I'm going to pass that negative clip plane, right? That's the negative clip plane value there, right? And so we're talking about this is away from the camera, so I should be able to put in 0.1. I believe that's the near clip plane. Again, we'll check that out, but I think that's what I'm looking for. So now I want to be able to go through, and I should be able to find, just by using this call right here, right, I should be able to get, I should be able to get that exact test case so I can look at what happens. So here we come through. Now we should see the debug transform coming through, which I can start with. It's a simpler transform, right? Oh, but it looks like it's never been set, so that's not going to help us. Hold on a second. There we go. So here's setting the debug transform. Now we can come in through the unproject. All right. So you can see here we've got our transform. Here's the debug transform here. It's got exactly the regular orthogonal unadulterated axes. They're exactly what they normally are. We have the p-value, which is at 8 back z, right? So it's 8 above the ground plane. which again is what we expect. Here's our world distance from camera. It's 0.1. We would expect now for the p-value to basically walk it back. So it's going to start at that 8, and it's going to walk back along the z-axis. So it should be 7.9, right, or something like this. Here's our probe z. There's that 7.9. There's the w value, right? So now when we transform this probe z out, I'm going to see what we get. So here's our probe z. And you can kind of see the values that we end up with here. Let's look at our clip z. So our clip z is exactly correct in this case, right? We're getting literally the perfect value out, exactly what I would expect to see. And off we go. So, you know, there we're going. And so now let's try it with the far clip plane. I think we said that was at 100. Again, I guess I need to set the breakpoint, so I set the debug camera first. And here we come through here. Let's see what our clip z is at now. It's at 1, so that's exactly what I would expect, right? So this is working exactly how I was expecting it to work. All right. So now let's pass a value in between those of 8 and see, is it just that the z is that ridiculously nonlinear that this is actually the expected value in between those two? I mean, it could be, right? So let's see here what we get. What's our clip z? So that's the right value. Wow, that is just nuts how much z resolution you start to lose after getting only that far away from the camera. Am I right? It's crazy how much you lose there. I guess that's how divide. It's the inverse square law kicking our butts at that point. That's just nasty. So no cause for alarm, I guess. But I guess there is a little bit of cause for alarm, which is just to say that that is not particularly good resolution for us on our z, and it suggests that 0.1 maybe is too close for comfort on that near clip plane. Let's take a look. I'm just curious if we continue down the path of fixed z buffer. I kind of wonder if our near clip plane maybe should be set something a little bit further out than that. I don't know if this is too far out, but I'm just curious now to know what our unproject value would be at 8 if we set our near clip plane up just a little bit. So not particularly great even so, right? Just not a particularly great value. I feel like this is just one good reason not to do the vanilla style z buffer and instead use something else, either floating point z buffer or w buffer or something like this, because that's just not a very good value. You know, the range just in there is just not great, right? If you think about how that's going to map, that just makes me a very nervous Nancy at that point. So that's probably something to look at. I'm going to go ahead and make a note of that in the to-do list here. I'm going to say so we should just think that through and try to come up with, yeah, something there. I don't suppose, oh, wow, that is lucky. I just happened to look over at the chat. I was like, I wonder if Alan is watching right now. And I just happened to look over and see Mr. Fourth Dimension is talking in the chat right now. Basically, here is a question for Alan, which is that, I don't know if you've thought about this at all. I know it's a weird problem, but when I keep to-do lists in this case, I wanted to make it so that the wrapping happened, like if it's dash space thing, there's the wrapping would like wrap properly. And I know that's kind of like outside the scope of where 4Coder's at right now, because in general the parsing is not in the custom layer. But I was wondering if you would consider adding a parser mode for to-do outlines that just whatever it is will comply with it. So like you could just say, oh, it's just double dash or something is what it is, and then it'll line things up so that wherever you have the double dash, it'll do the wrapping properly on those, because you've done all the work to make that happen in code. And I'm just wondering if there's a way that you could make it for to-do lists so that it would auto-indent them properly. You know what I mean? And I don't know. I'm not even sure what I'm asking for. I'm asking for someone to think this through in a way that I could get something out of it. Maybe it needs an open, thing here. I would be okay with putting those in. Just, I don't know, something that's like a good format for indent, for outlining, that could be used to keep lists, because I find myself doing this in 4Coder now, and it would be cool to have good layout for them. So I wouldn't really care if it conforms to any standard of mine. I'd rather just like someone, and in this case I guess it would be Alan because he's the one who implements the parsing, but to figure out what's a way I could structure simple outlined lists in a way that would allow them to be formatted properly in 4Coder, and I'll just use that format. Like I'll just convert all of my files with lists to that format and use it, right? Because that would be pretty great, and 4Coder already has all the features. It just only has them for code, right? That's it. So anyway, that's all. I was just going to throw that out there. And I noticed you guys were talking about the virtual whitespace. I tried turning on virtual whitespace a few builds ago, and the problem was it couldn't save in a way that you could debug yet. And I think that might be fixed now. So actually, I just updated 4Coder today on both my work machines and here. And so I probably am going to try returning on virtual whitespace because I really want to use it. And it was just the debugging that was preventing me from using it. So if that's actually fixed now, I probably will go to virtual whitespace like now, basically. But anyway, that's a separate issue. All right. Anyway, near and far clip plane distance being what they are, maybe we'll fuss with these a little bit later and figure out what the problem is in terms of getting more resolution there. That's an issue we haven't really talked about much, and I don't need to go into it now because we're not having any actual bugs with it. But I wanted to put that on the to-do list because we probably will have some bugs with it, and so we should actually get our Z story straightened out, right? That being said, looking in here now at what's going on, here's, everything seems to be sort of a little bit more solidly working now, and that's all fine. But now let's go back to what we were trying to do before and debug the other problem we were having. That is that when we were creating these screen indexes, right, I had a problem where as I start to add screens, I'm going to try and stack them on top of each other. We were getting some problems, like, for example, I don't know what is happening here. I have no idea what we're seeing here. But we're getting some kind of weird situation where we've got, like, the camera encased somehow in some degenerate geometry of a layer or something. I really just don't know what exactly the bug is that we're getting here. But we're definitely getting some kind of a problem. So when we stack multiple worlds on top of each other, we get a bug, right? And we need to start debugging that because that should not be happening. The other thing that we probably want to do here, I wonder door direction equals 3. What is door direction equals 0? Which are which here? So door down is 3, door up is 2. What happens if I do the other direction? Just curious. So it's only if they come up closer that it's a problem, right? And you can see our Z offsets may be a bit aggressive there. You can see that it's too much Z stand up. It's actually large enough that the height, although the height between, I don't know if that's a reasonable height between floors here. That might be a little bit low ceilings, if you will. But yeah, you can see that that's too much offset because they start to poke through the Z here. So I feel like also what we want to do is calm that Z offset down. That's in the push bitmap. Oops. Stuff here. So here's where we're actually doing that z-bias. You can see the z-bias here being set to the height. That's obviously like way too much. So I'm not sure what we want to do, but we want to calm that down considerably. That may be too much calming down. Again, this is just a way of biasing those values. So we're going to need something that sort of, let me zoom out a little bit here. So that also looks a little bit wrong to me. So our bias, I think in the shader, our bias is being applied incorrectly, because the bias should not change how we see things based on zoom, because that should be consistent. So I feel like we should double check how that bias is being applied in the shader as well. Let's go take a look at that. So here's our code for that. Here's the vertex code. Oh, interesting. ForCoder will now treat this as actual code. Is that true? No, maybe not. I think it gets confused by the R strings. It looks like maybe. I'm not sure. Anyway, I think it used to just treat them as regular strings. I'm not sure about that. Anyway, so taking a look in here, you can see where we're using this z-bias value here. When we output the position after the transform, we take the z-vertex and we add the bias to it. It should be being added in world space, right? And then it gets transformed through. And that is what we give our transform z. Right? So we do the transform on both of these, and we just take the z from the one that's been biased. And so to be honest, that looks correct. Right? So if you look at how GL position is working here, right, you can see that this is being pushed in what I think would be correct. I guess that could be z-phi, but this is a z that's getting transformed properly. So in theory, the min and max transform here should be working exactly as we would expect, right? The min transform for the z, it just does this transform on the original coordinates, whatever they were, right? Not adulterating them in any way. And then, yeah, the z bias here is only used, as far as I remember anyway. Yeah, it's only used when we're actually outputting those top coordinates, right? And it's as the z4 value, the v4 final value of those. So that should be right. When we look at what happens in here, all we're doing is extracting that w coordinate, and we're passing that down as part of just the z value, which should only be used for the depth buffering, right? That's the only time that should be used. And it's going transformed through the transform in the standard path. So again, that should just work. I don't know why that would be at all related to zoom. The only thing that happens with zoom is the z buffer precision will drop there, but that's it. So I want to know if that's related. I don't know if it is or if it isn't a z buffer precision thing. I don't think it is, but I want to verify that it's not. What I'm going to do for that, to take that out of the possible set of problems, is when we do the z buffer, I'm going to make it use a floating point frame buffer so that it's less likely to be sensitive to where it is in that range. Although even that's not really probably what I want. But let's take a look and see what we can do here. So when we actually create these frame buffers, you can see depth component 32 here. And I don't know, I'll try setting it as an F32 just to see if there's any difference. Is that... let me find out what we've got here. GL depth. Oops. No. 32F. They put them on the opposite side, as do I. There we go. I just want to see what the difference is between floating point and non-floating point at the moment. So it's the same in both cases. So that's puzzling to me. So that feels like I'm doing, again, I'm just really concerned about this. It seems like we're handling those Z values incorrectly, and maybe that's a problem with the projection matrix. I don't know. But that's just not what I would expect to see, right? Because that Z bias is getting applied in world space, or at least I thought it was. But in actuality, from what you can see, is that bias is dependent on the camera's distance, because this is not rotating at all. So there shouldn't be really any difference in the values that are going in here. They're just getting projected differently, right? That's the only thing that's happening, is they're getting projected. The projection matrix is having different Z offsets, right? Or the camera transform composite, projection composite matrix. I'm getting different values there. And you can see very clearly that the offset almost looks like it's being applied sort of in screen space, if you will. So that as things got closer together in clip space, it's like it was applying it there. Do you know what I'm saying? And that doesn't make any sense to me. I don't know why that would be the case. So that's a bit of a puzzler. And it's impervious to whether we're floating point or not. So I don't think it should have shown at least some difference in the artifact. I feel like if it was a Z-buffer precision issue, then changing between floats and fixed should presumably give you different results, I would think. But I'm not sure. I guess I can't really verify that that's 100% true. I would have just expected to see something slightly change between them, but maybe that's naive. All right, anyway, so moving on here. So the question is, why are we getting that? Why are we seeing that difference, right? What's going on there? And so what I want to do, let's start with some simple tests. If I just said don't bother with the Z vertex situation at all, so don't actually bias them, I'm curious, do I see any difference there, right? And the answer is no. So if we look at what happens in this case, all of the stuff seems pretty consistent. And I don't get any, I get a regular 3D scene getting rendered exactly as one would expect here. Right? I don't know if any of you guys see anything wonky, but I don't. Everything seems pretty good, right? No weirdness yet. So I'm happy with all that. That all looks relatively good to me. And so then the next question is, okay, when we are doing this Z bias, why wouldn't it be transforming itself normally? Why would that Z bias not be in world space? Or what is the thing that makes it appear like it's not in world space? Right? It's being added to Z vertex, the Z coordinate of Z vertex. It's being added before transforming, so it should, in theory, go through the full projection and everything else, and it should get minimized down to a value that's relative to its distance away, right? And so I just don't see why that value would change based on the distance from the camera. So I guess one thing is how far away those things actually are from the camera, and how close they are to the far clip plane. It could be that it doesn't really matter what the, yeah. So I guess let's just try some stuff in terms of the Z precision there. And we could also try doing an infinite far clip plane to try and increase the Z precision. I believe it was Sean McGrath who was saying just always use one. And I do happen to always use one in actual work. But I just do it because I don't want to bother thinking about far clip planes. Not because I was trying to get more Z precision, but, you know, whichever one works. So let's go ahead and take a look at what I could do there. So if I was going to just play around with that a little bit, if I go into the math where we create the projection matrix, what would happen if I just push the near clip plane out quite a ways, right? So, you know, get the near clip plane out to a very large value, right? Oh, I've got to re-enable that Z bias there. Oh, I already did that. Okay, so that's even weirder. Like, I don't know why we were getting a line there. Look at this. Look at how odd that is. Oh, that's just the front. That's just the near clip plane clipping through. Never mind. So again, just really weird behavior here. Oh, the Z. Oh, I know what this is too. The Z biases, we reduced that quite a bit. Let me take a look at that Z bias there. Let's restore that back to the height. I don't know if that clips through at the outset or how much that clips through. These are just really weird results. I'm very confused right now. Is basically what it boils down to. Oops. And I think something's wrong, but I'm not sure how to go about looking for it. So I think we're going to have to play around with this a little bit. I don't know what the correct Z bias value should be here. Probably want to take a look at that a little more closely. But there's that near clip plane. It's quite far out. You can see it clipping the geometry there, right? So it's very far out right now, further out than we would want. And it looks like, again, when you zoom out to about here, you can see those pretty clearly, right? So what happens, let's just see. So here's the first place I start to see some of that popping. I'm very curious to know if I just went into math right now and set these back to what they were, does that change? So it really does seem to be about our Z, right? So it looks like this is just a Z precision issue to a large extent, which is nuts to me. I feel like we must have something kind of busted. Let's take a look at how our projection matrix compares to a standard projection matrix. Maybe we did something really wrong with how we mapped it. Or maybe that's just normal. I don't know. It just seems that's just nuts to me that would be that sensitive. So I still think something is kind of weird here. Something's going on that doesn't make a lot of sense, right? It just feels like things are mapped in a very weirdly nonlinear way. So let's take a look. Standard projection perspective projection matrix. I don't really know of particularly what any of these are going to be, but you know, it should be, anyone should be fine. I don't know if there's anything. I just am looking for a we're talking about various standard perspective projection matrix. Let's see. So this is what we want, right? Near plus far over far minus near. And I want to just correlate it with ours. So near plus far over far minus near. Not quite the same, right? We have near minus far. And this is 2 times near times far, which is what we have, over near minus far. So this is backwards. The fact that that's backwards, probably, though, it's just that we have a -1 here. Do they just have a 1 there? No, they have a 1 there. So I'll be honest, I'm not sure how we could both be right about this. Did they flip the z range from what we normally do? Because they have exactly what we have. It's just there's an additional negative, right? Because they've got a far minus near there, and we have near. Let's check another source. Again, I'm just randomly picking sources here because I don't know if any of these are particularly reliable, so I'm just seeing what people in general are doing. Let's see, no. Somebody please just show a standard projection matrix from OpenGL. I think I tried this before, but we couldn't get one that was properly written out. Yeah, it was like it's all the... Everything's all munged together here. Stack Overflow doesn't have the diagram. That one doesn't. Does anybody have the original formatting? All we just need is the original format. There we go. Oh, but yeah, but this one's missing what's on top. So theirs is at least the same as ours, and it's near minus far in both cases, which is the same thing we came up with. So I think maybe that slide just had a bug, or they were trying to map the range the other way around, which, you know, maybe is what they were trying to do. I don't know. I wish someone else would have the actual top values in there, though. But it doesn't look likely. Oh well. So I don't know. I'm very weirded out by all of that. Well, as far as I can verify from not particularly good sources, though, other people do exactly the same math that we worked out, so presumably there isn't a lot of variability there. So I don't really know. I'm just not sure what to make of that. So I guess one thing I would like to see is if we did... Oh, well, probably shouldn't leave the near clip plane quite so far out there. So with the near clip plane operating in this fashion, that just looks backwards at the moment. It feels like we've got something messed up, right? Like, maybe we really do have maybe we are mapping the range the wrong way around, and OpenGL actually wants it the other way, right? Like maybe we do want one of our values to be negative, right? Like maybe we do want that instead, or something ridiculous like this. I don't know in what universe that makes sense, but you can see it's a little bit wonky. Well, this is a puzzler. I would say there's a number of reasons why it's a puzzler for me. I want to double check one more thing. I want to turn off the z-bias one more time just to make sure. Actually, I guess you know what I'll do? Let me turn off the z-bias in the following way. So if I come through and I'm in render group and I look at z-bias here, I'm going to turn it off at the source here. And so here you can see that everything is sorting exactly as you would expect. And it's not sensitive to how far I move away, right? Everything appears to be correct in that sense. And it doesn't matter how far away I get. I can get out. That's the far clip plane right there. We're hitting it. And it's totally fine, totally stable, right? No issues. Now, the instant I turn on the z-bias, suddenly, even the base, like something's really borked here. Because even the bottom of these sprites, now the bottom of the sprites, again, shouldn't be affected by z-bias at all. Because the bottom of the sprites have a z-bias value of 0, in theory. So something's really messed up there, because that's clearly not what's happening, because the bottoms of the sprites are wrong, not just the tops of the sprites. So the z-bias is just, there's something fundamental, I can pretty much guarantee it, that I'm not understanding about what's going on with the z-bias. Like my mental model of how it's working is not the way it's actually working. Because that shouldn't, it should have no effect on the bottom parts of the sprites, whose z-bias value is always 0, right? So something's really screwy there, because that should not be happening. Yeah, I cannot think of what the problem would be there. And again, that bias is entirely pre-transform. So this is in world coordinates that are coming in. So when it's biasing in Z, it's not even biasing it towards or away from the camera. It's biasing it upwards in world space. That's the only thing it's doing, right? And it's biasing it, so, right, because it's pre-transform. So it shouldn't have any effect at all, even which camera we're using, whether we're using the debug or the release or the game camera, shouldn't actually have any effect, because it's the world space movement is where it's happening, and then it gets transformed by the transform. So the transform part is separate. It's not, z-bias isn't dependent on that. Unlike the vertex coordinates, which are, right? The vertex coordinates are dependent on that. I'm trying to think if that is at all relevant there. So in push bitmap, right, we are using the X and Y axes here are based on the camera. So there will be Z displacement happening as you rotate the camera around and those sprites turn to face you. But in the case of what we were looking at, you know, the camera's looking kind of down on the world, there isn't going to be any Z displacement other than for the Y-axis. The Y-axis will have some, but it will be very little. Again, these axes are coming from the game camera, not the debug camera. So as the debug camera becomes more oblique, those things aren't pitching to follow it at all. So that shouldn't be affecting it either. So I really just cannot see why we're getting that extremely odd result. It really looks like the Z bias is getting applied in clip space. That's what it looks like. But I just don't see from looking at the math, I'm not figuring out how. There's like something about that I just don't get. So in order for that Z bias to be dependent on the camera distance, it has to somehow be getting past the transform, but as far as I can tell, it's always behind the transform. So I'm just not sure. Oh no, I am sure. Wow, that's subtle. I am sure now. Well, that's premature. I have a good idea of why. Let's say that. So, not quite. This Z value is counting on the W value to counter divide it in order to get the right position in clip space. However, we are passing the W from the other, we're passing the W from the upper coordinate because we want the Z-min transform X and the Z-min transform Y to get divided by this W, right? So what we actually want to do is we actually want to pass the Z value here, which when divided by the other W gives us the same result as if it were divided by its W, right? So, oh man, you can tell I've never done a Z bias in the shader before because otherwise I would have known this already. I always like learning new things. Oh wait, I already did a days 374. I don't need to write that again. What am I talking about? Well, I'm talking about this. What we did when we solved our equations, right, is we said like, okay, we want that clip Z, right? The way we're going to get our clip Z is we're going to take our Z value and we're going to divide by our W value. Okay, so what that means is we have to solve so that Z over W properly maps between -1 and 1. That's what we said we were going to do, right? What that means is that W and Z are inexorably linked in this transform. You can't modify the Z without modifying the W, or where you end up in clip space will be totally different than where you should have ended up for a different world space Z. You can't just modify the Z you're transforming in without modifying the W, because they have to, the divide has pieces that have to cancel out, right? So what we've got here is we've got a Z, a bias Z, if you will. We've got like a Z prime over a W prime that we want to equal a particular value, right? Like this is our C, this is our value we're trying to get out, right? But what we're actually going to do is we're actually going to be dividing that Z prime by our original W, right? The unmodified W. So what we need to do is we need to make some coefficient here that we can multiply this z by such that a times z prime over w is going to equal z prime over w prime, right? We need to modify the value so that it will actually come out to the thing we want it to come out to, even though we can only divide it by this value. So what if we multiply these out? If we said az prime w prime, right, I'm just cross multiplying, equals wz prime, right, in this case, the z primes would cancel here because, you know, they're the same in either case. So we'd get like a prime w prime equals w, right? And that a prime value is w over w prime. So what we actually want here for our z prime value is, once we have our z prime, we need to multiply it by w over w prime to put it into the correct space for the divide, right? So in this case, we know what those two w values are going to be post-transform, right? We had z min transform, z max transform. We know those two w's. So we need, in this case, our z max transform z. Right, we've got our special, like we've got our modified z here. And that's going to come in here. So our modified z in this case has to be the original w, right, divided by the new w for this one. And that coefficient then multiplies the z value we actually have to get our modified z. Right? Okay. Let's see if that helped. Hey, guess what? That was exactly what we needed. Rotation in this case won't really work properly because, again, that bias is expecting the camera to be placed straight up and down, I believe. So we do have to account for some of that. And we also now, you can see some things that we will definitely have to deal with, which I'm not sure how we will deal with exactly. This is a pretty good point, actually. I'm not sure what to do here. When we have things like in this situation where you've got a block that would be obscuring one of your other blocks, something that's raising up here, that actually is, I guess, what would happen, right? The z value, as this thing goes up further, if it extends past into the other block, you would get that bug. Right? These sprites are bigger than the block they're on, which is not really correct. Like, that should not actually be happening. But the result there that you get, and you can see it there, right, is as that comes up through the other block, it will pierce through it, right? I'm trying to think if there's ways we can make that less likely to occur. I think we could. And I think the way we could do that is by saying that, you know, we could have that z bias being more directional, if that makes sense. Meaning that z bias we could correct that to be more like we were actually tilting the sprites in the way they actually are supposed to go, rather than just biasing the flat z projected coordinate. I'd have to think about that. We may still want to play with that a little bit more. But at least I'm glad I figured out what that problem was, because that was really bugging me. But now at least we know that that's not bogus anymore, and that's really good. But like I said, we still kind of have a problem here and that I'm not sure exactly how to fix. While we're on the subject of these, we might as well look into it a little bit more, because I would like that to be correct. We are mostly correct here, but when you have a block that's much lower than another block and you're looking at them sidewise, and again, it's not happening in very many places, but there's just a couple where you can see it. And so I'm trying to think of where there's really only one that's really pronounced. But here, maybe this is a good one to look at. So you can see this tree is on a block that's much lower, right? It's on a block here. And so when it comes up, it comes through this because you can see its placement in the world. You know, it's going to be, you kind of want it to appear behind this block, even though that's kind of wrong. The reason that you get that is because the tree should be sort of sticking up perspectively this way, right? It should be tilted. And at the moment, it's not. So I guess I also wonder, you know, could we tilt them? Could we leave them tilted? Is that a better plan? I don't know. It might be. Or slightly tilted. I'm just going to quickly play with that just because I'm interested to know. So if we were going to leave them slightly tilted, then basically what would be happening there is so we're using the X and Y axis of the camera here. And so what we could do instead is use a little bit of what the actual Z axis is. And make that be what we use for the y-axis. And so in order to do that, we need to kind of give the y-axis a little bit of the actual z. Or I guess the other way to say that would be give the y-axis a little bit of what it actually should be rather than strictly changing it to be entirely in the camera's plane. Right? Because what we're doing at the moment, if you think about sort of how these sprites are getting generated, right? If I'm looking at one of these blocks and I put a sprite on it, then really, if the sprite is standing upright, it should be entirely perpendicular to it, right? So, you know, this is the coordinate system that we should be seeing for this sprite, where here is the y-axis, here is the x-axis, here is the z-axis. What we're actually doing is the sprite is aligned with the camera, so it gets a y-axis that's very much not that, right? So its x and y axes are completely different. Now, if we actually were going to do it, like, you know, here, let's just show what it would look like in the case of if the x-axis and y-axis in this case were actually what we would expect. Well, I guess it's just what the, well, here we go. So basically, if it's an upright sprite, then really the only difference here is we're doing exactly this. The x-axis still is what the x-axis is, but in this case, the y-axis, instead of being just you know, the x in the x and y plane, the x-axis and the y-axis in this case are going to be in the plane of z and x instead of y and x. So we're basically looking at something like this. Right? And so if we take a look at what that looks like, here is, at least I think I did that right. Did I do that right? No, I did that in no way correct. And that is because those values need to be undefined. There we go. Okay. That's what I wanted to show. So you can see, like, this is what would happen if the cards were actually just standing upright. And we wouldn't need the z-bias in this case because they're just in the world the way they're supposed to be. But the problem is when you look top down, it's ridiculous, right? I mean, that is not at all going to be a playable scenario to have 2D sprites mapped in that way, right? It's just silly, right? It doesn't make any sense. But that's where they should be. And so you can see why we, if you take a look at where we were getting problems before, let me go ahead and zoom down in here so you can see. So you can kind of see the way these sprites should be standing up in the positions that they're at. You can see how you get away from the clipping problem. It's because the sprite goes out into the side. And so in our case, when it's down here, it's coming straight up this way. It pierces straight through this cube instead of going out into the side. But there might be, like I was sort of saying, maybe there's like a middle ground there. You know, maybe you can take the x and y axes and like blend them together or something like this to produce a composite version that has still a lot of the properties of the camera transform, but doesn't have as many errors. I don't know. But you know, let's say you were to do this. right? What I could do then is I could do a linear blend here. I never know what we call this. Every time I have to look it up. I don't know why we called it something that I don't recognize. Lerp? Yeah. So if I wanted to lerp these two, you know, I could do x-axis 0, x-axis 1, and go halfway in between them. That's probably way too much to go, but I'm just want to see if this works at all, like what it does at all. That will like kind of combine the two ways of doing those axes in not a particularly good way, but it's fine. So there you can see sort of a combination of the two, right? And it's, you know, just still gets a little of that upwardness. So I guess, you know, what you could say is, well, what if we went, you know, most of the way towards the camera facing one, you know? And you can see there now it's sort of a little better. Like it's still not great because it still has the clipping problem a little bit there, but you can see it kind of goes up to the side more, which maybe is a good thing, you know, I don't know. So we've got some stuff to play with there. Like I don't know to what extent we want that. The other thing we could do is say, oh, you know, maybe we'll only use the that z value from it. Maybe we'll do that and you know, play with that a little bit. So, you know, maybe the x-axis actually equals, you know, and in fact, I guess the x-axis itself doesn't have to do this. Maybe the x-axis is always x-axis 1, and we only play with the y-axis is first, so that would look like this, right? Here you can kind of see what that would look like, right? So the trees are still kind of slanting a little bit, and that's kind of cool, right? That starts to look more right, potentially, to me. I don't know, a little bit hard to say. But it's starting to look a little bit more right. And maybe furthermore, maybe we just add in the z part. So maybe the x-axis, the y-axis is also just the original, but then the y-axis z is just a lerp between the two of these, or something. You know? And again, since we're trying to like simulate a 3D look with 2D art assets, it's hard. There's no right answer here. We're just trying to play with sort of ways we can hack those values. But that kind of looks better than what we had to me. Getting a little bit of that slanting to the side in there just feels a little bit better. So I don't know. I feel like that's sort of a thing that, you know, kind of looks cooler to me. And it gets a little of that bend in as well, so I kind of feel like that's maybe good. Also, the z-bias doesn't have to come in there. I don't know what the right value is lerp-wise for that. You know, maybe we want even more of that in there. There's more of a slant to it, right? And that looks a little bit too much, certainly. But, yeah. I don't know. Having a little bit of that lerp does seem kind of good. So I don't know. I may want to leave that in there. We'll find out. Just the slightest bend. And so, again, just so you can see what that's actually doing, here's the debug camera. So you can see that now what we're doing is we're still aligning with the camera, but we're just giving it a little more of the upward tilt than it. So they're standing upright a little more than they used to stand upright, right? So we're kind of artificially inflating that stacking from what it was. That's all that's happening there, right? So I don't know. All right, let's go to questions. Today we ended up investigating something I wasn't even planning to investigate, but that was pretty educational. For me, because I've never tried playing with a 2D Z-bias kind of a thing like this before, so I had no real expectations of what we would see there in terms of problems. And that was really interesting. I was like, oh, right, because this is going into clip space. The W and the Z have to work together. You can't just shove one of them in there. That's not really going to do what you think it's going to do. And so that was pretty good. I'm glad I learned that. That was cool. All right, so let's see. Question: I am a fairly amateur programmer. I have dabbled in Java, flavors of C, Python, and Ruby while I was in university. My question is, how would you suggest with progressing your proficiency in a particular language? Is it best to follow tutorials? I guess what I would say is, it depends kind of where you're at. Certainly tutorials and like reading other people's writings on how they did things in this language. When you're earlier on in your programming education is important, because you won't think of all of this stuff on your own. And you want to kind of learn from the people who have already done a lot of thinking about it. As you get further along in your programming, one of the problems is there's just a lot of bad ideas out there too. And in addition to ideas that are just objectively bad, which there are, there's also ideas which are subjectively bad. So there's ideas that are just that no one should be following. And again, if you're a beginner programmer, you don't really know. And so when you're looking at tutorials, you may just be seeing just really bad ideas. But then there's also just the question of how you like to program and what you find effective for you getting stuff done. And that's subjective. And so that's the other problem with following tutorials, is you may be learning techniques that subjectively don't work very well for you. So you kind of are in the situation where as you move forward programming, you have to kind of get both things working together. You need to first find reasonable sources of new ideas that will give you ideas that you don't have yet about how to program and techniques you can use to tackle various problems. Right? Handmade Hero is one way of watching somebody program C. You can see the kind of techniques I do. If you haven't thought of these techniques before or haven't been exposed to them, now you know them. And you can go, do I think that's a good technique? Do I not think it's a good technique? Later, and kind of integrate it into it, right? There's lots of other sources you can go to. There's other people you can watch program on Twitch. There's tutorials you can go read, et cetera, in all kinds of different languages, like you said, depending on which language you want to learn at any given time. I would say probably pick one and stick with it for a little while. It's probably not a great idea if you're trying to learn to be a better programmer to be bouncing around to lots of languages, because that's adding more complexity. So I'd say maybe pick one language you want to focus on for a little while first, and then maybe expand out a little bit later. But then, what I would say is also, as you're gaining more of that sort of exposure to techniques, try to start being critical of them, right? And not necessarily critical of them from a this is good or bad in an objective sense, but critical of them from your perspective. As you practice programming and try things, go, did these techniques learn well for me? Which of these techniques are working and which of them aren't? And start to develop a good mental process there where you go evaluate. Don't just do something because you saw it on this show or another show or in a tutorial. It may not work for you, right? And so start to develop a good habit of assessing programming techniques for your own use. Are they working for me or aren't they? And that is very important to learn, because if all you ever do is just use techniques you saw because someone said they were good or something, that's going to hold you back. because the chances that all the things that say I find effective when I'm programming, because that's the way my brain works and it's the way I program most effectively, the chances that that's going to be exactly right for you are low, right? There's probably different ways that you will conceptualize problems and different ways you will solve them that might be subtly different from mine or very different from mine. And if you don't have a good way of moving yourself towards those, you're always going to be held back by programming in my style or somebody else's style or some mix of styles that isn't the right mix for you. And so I don't pretend that that's easy to do. It's not. It takes a long time to come up with that taste of like what are effective. But I would just encourage you to do some objective analysis there. Take time in your programming to actually try to measure. Write some code specifically using a couple of different techniques and compare the results. Which ones went better for you? Which ones do you like the looks of more? Do you find you can manage more easily? You know, which ones are easier for your brain to wrap around? And that I think would probably be good advice for basically anybody who's kind of coming to that point in programming where they've gotten enough exposure that they kind of know what's going on, but they haven't really turned that corner to, I know what's an effective way to program for me, you know? Hedge 1993 asks, what is Z transform? Are you talking about in the OpenGL layer? Are you talking about this here, or are you talking about like the min-max transform? That's the only thing I know of that would fall under the name Z transform. In this case, what's happening, this is the vertex transform code. So all the vertices that come down for all of the sprites in the game pass through this piece of code. And what's happening here is, you know, normally what you would see in just a vanilla shader is you just literally see like this line of code. You just see transform times the vertex. And this transform is the full transform. It's the camera plus projection transform in one matrix. So it's the thing that takes world space on one side, which is here, and transforms it into clip space for OpenGL on the other side. This, however, this transform times in vertex here, that doesn't help us do our fake sprite z-biasing, because remember, we're 2D art, but we're drawing in 3D, which is a weird hybrid place to be. So you end up having to do some weird hacks to figure out how to make things harmonize properly in that world. And so what we do is we transform twice, once with the real world position and once with a offsetted world position as specified by the input vertex. So the input vertex's W coordinate is actually secretly a Z biasing value. We do that and then we compute what the Z value would be if it were actually offset by this Z bias value that's coming in, and that's what we use for depth sorting. So it's just a way for us to make sprite cards which are not standing upright appear like they're standing upright in terms of sorting, even though they're not drawn that way in terms of spatial, right? How many draw calls with the profiler open? We're not really counting draw calls yet, unfortunately, so we don't have a way of doing that. We could add a counter for that, but we don't have one at the moment. Abarishu, a few streams ago you showed a function that tells OpenGL to call us back with messages. Do you think it can help debug OpenGL issues instead of sticking GL get error after every call? Yes, in fact, that's exactly what it's for. The whole point of that debug callback is if you are asking for an OpenGL context that supports that, and in our case, we just ask for the extensions there, and if the extensions there, we turn it on. If you have that extension on, then you should, most of the time, because we also enable the synchronous debug reporting. So if that happens, then what you should see occur is, as much as the driver can, it will immediately interrupt the flow of the code and call that back as soon as you've done something wrong. So you should be able to avoid having to spam GL, get error everywhere, if you have a driver that supports error reporting via the debug error callback. So I highly recommend turning that on if you have it available, yes. Arif, when the new assets going to be ready? The new assets are ready. I just haven't had a chance to actually use them yet. So eventually we can switch to them. I just haven't had a chance. Holst 80, scenario is that Handmade here is expanding to 3 programmers and 2 need to understand the architecture you have designed. How would you recommend that they get into the code and understand the architecture? What would you need to do to prepare the system for such a scenario? So I guess my answer to that would depend a lot on the programmers, right? So, if you're like, well, the programmers are like, Fabian and John, I'd be like, nothing. They would be fine in here, right? There'd be nothing that would need to happen. They would just know what was going on and they would be fine, right? And they would have a bunch of things that are in the code base are not the way they would want them to be done, I'm sure, but they wouldn't be surprised by anything and, it would be whatever. If instead you told me like, okay, these are 2 like interns from like college or something, so they may have no idea what's going on and aren't super familiar with, production programming and whatever, then I would probably want to do things a bit differently. So first of all, I would want to know what are these people going to be working on, right? And once I know what they're going to be working on, I might go to those sections of the code and harden them a bit. So I'd pull out the parts that I expect people to mess with and make those sort of clearer and probably provide additional API design work there that was intended to clearly articulate to the novice programmer what these sections of code were supposed to do and how. And I would probably add a few top-level comments to some H files that would say, here's how this API is meant to be used, just so you understand, right? So, I guess that's what I would say. If we went further and said, I'm going to ship this engine to people and they're going to build their own games on top of it, right? I would want to do a lot more work. So in that case, I'm now thinking about like a maintenance style project. And I would want to really sit down and work the APIs and decide exactly what the boundary was. And because right now, right, when it's my code and I'm the only one working on it, then keeping everything fluid until I want to lock down a section for some reason, like testing or something, is always the best way to go. Because otherwise you're just burning friction on doing a bunch of work that doesn't need to be done, right? And one of the common mistakes you see programmers make, not just beginners, but even people who've been programming for a long time, you end up in circumstances where you'll see them spend a lot of time on code that doesn't do anything because they've been trained that there's a certain idea of what good code looks like without appreciating the fact that there is no such thing as what good code looks like. Code always has objectives, and what makes good code is how well it matches those objectives. And so if you're doing stuff like declaring private operator equals for classes that you are only using internally and are never going to make an operator equals error for, you have just wasted your time, right? Not to mention added code that adds complexity to the code base that doesn't do anything. And so it's very important to always keep in mind, what are you trying to accomplish? And what code will accomplish that with the most efficacy, right? And so that's why I say like a question like, oh, you need to have other programmers work on this or things like that. I always want to know, well, what am I actually trying to deliver to these new programmers? What kinds of programmers are they? Because what I'm going to deliver and the changes I'm going to make to work with more programmers are going to be very dependent on who those programmers are, how much do I expect them to understand what I'm doing, how isolated do I need to keep the code from them, how much maintenance work do I need to do across the boundary, blah, 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 blah. All of that comes into play. And it can range everywhere from I'm shipping an engine to external people who have no idea what's going on, who may be very beginner programmers. I need to maintain the code for them, blah, 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 which is the hardest core level of hardening I'm going to do there. All the way to my friends are coming to work on this thing. They're experts. They know how to code this as well or better than I do in all cases, and I don't have to do anything, right? They're just going to go, and it's going to be fine. And we'll have some friction along the way when they expect something to work one way and it doesn't, or I expect something they wrote to work one way and it doesn't, and we'll have a little bit of a snafu there, but it's minor, and any time spent trying to avoid them would be a waste of time, right? All right, I'll take one more question here. Ron Paul Vivo, I know you don't really like object-oriented programming design, but can you provide some ways you might take advantage of OOP design in Handmade Hero? So I guess what I would say is I typically try to say the same, to hammer home the same point about object-oriented programming whenever it's discussed. The problem with object-oriented programming is just the object-oriented part. I've tried to say that a lot of times, and I'll say it one more time just to try and hammer it home. And that is to say that there isn't any specific element of the object-oriented design results that is particularly problematic. Like, there are times when you want to hide implementation of things. There are times when you want to have things broken into pieces that are decoupled, and you want to do. There's times when all of the things you might see in a object-oriented programming could be relevant to a good design. The problem with object-oriented programming are not those things. Because you can see some of those things crop up in Handmade Hero. Sometimes we end up isolating a piece of the code, or we end up keeping a little thing that's kind of like, it might look more like an OOP style result. Like, here's this thing, and its interface is kind of well defined, and it's, kind of off in its own piece of the code, so it's not intermixed with anything else, and blah, blah, blah. And it starts to look more like what you would see in the result of after an object-oriented design programmer did some stuff or whatever, right? So all those things are fine. The problem is the mindset of object-oriented design. The idea that the way you should be approaching the code is by thinking about what the objects are and how those objects are working, that is the problem. So I would say it would never be good on Handmade Hero. There's never a time when I think you should think about the code base in that way, literally. I never think that approaching it from the perspective of the objects is ever good. But in terms of things like, I want to sort of break off a piece in a reusable way that's, very specific about what is part of it, and it doesn't let anyone outside of it touch the way it works because it's trying to, be sort of hidden in that way. Those things all might be reasonable, right? Those things might all have times when you want to do them. And whether or not you want to do them depends a lot on, for each individual element of that, is the thing that you're getting from that delivering any value, right? And to give some a little bit more perspective on that, I guess, just to clarify, if you took something that's typical in object-oriented C++, for example, right? You took something like, I want here to use a private section, right? So I'm going to take all of the variables in this thing. Let me think of an example here. So here we are in game mode world, right? And I've got all this stuff in here, and I want to start making it so that I know that no one else can touch anything in here, right? So you'll see stuff like, object-oriented programmers are like, all the data has to be private. That's just, it's object-oriented. This is an object, so it's all got to be private. And then there's a public section, and the public section is going to have some stuff in it where the functions, what you can call. So if you want this null collision, you got to call get null collision or something like that, right? That's a thing that just an object. If someone's a serious object-oriented programmer, day by day, you'll notice they hardly ever write anything that doesn't look like that. They start that from there, that point. And to me, it's just like, well, what do I need those features for, right? The only thing that declaring this private does is it makes it so that I know a priori that no code that isn't declared inside the game mode world struct itself as a member function is touching them. That's what it does, right? But I don't really have any problems with that day to day, right? When I'm programming, I don't care if people are touching this. Any code that wants to touch standard room definition just can. And then you see me do this many times if I'm like, well, you know what? I want to start to regularize how standard room dimension is working. You'll see me do this all the time, right? That just generates an error everywhere anyone's accessing it, and I look to see what they're doing. Now I know, right? That's it. It's that simple. And if I want to now pull that out into something that has to get accessed in a structured way, I just do. So I really never see the point in doing the sort of rote mental application that object-oriented programmers say is good to always do these things. They just don't help at all. I've never found the circumstances where it was good to do that up front. It's always good to do it after the fact, if it's good at all, right? So when I am going to start doing those things, I would always do them last, not first. So object-oriented programming to me is just a bad idea. You know, if anything, the time to do it is at the end. So it would be object-oriented cleanup, right? Don't ook might be the thing if you want to do something object-oriented, right? So I think that is kind of the philosophy that I have when programming. Certainly, it's what I've found to be most effective, is that any work you do thinking in terms of objects at the head end is almost always too much code to get the desired results, inflexible code that introduces boundaries where none should exist yet, tortured thinking. Like a lot of times you see someone who's approached a problem object-oriented and you're like, wow, this is a really overcomplicated, unnecessary set of code to do this simple operation, right? And again, I think it's just because objects are not the right way to think about problems. And that's not the same as saying that you should never end up with any. You might, right? The right way to structure the code might look like the result of some object-oriented stuff. It also might not. And the key to it is developing programming practices that get you to a well-working, nice design as quickly as possible. OOP never seems to do that, as far as I can tell. That doesn't mean that the principles that happen in object-oriented programming are never applied, should never be applied, or anything like that. They very well may be. And that's an important distinction to understand. All right. Yeah, it looks like everyone kind of we're relatively on board with that too. So hopefully that answer was relatively complete. And yeah, I would say that unfortunately that's not the way OOP principles are taught either, which I guess also gives them a bad rep in some sense too, right? Because, you know, if you think of all of the possible techniques that OOP implies as bundled with the design philosophy of approaching problems this way, it might appear that they're all really bad, right? If you're an objective viewer thinking about that together, you might be like, this is all really problematic. It doesn't feel right to code this way. The results seem to be bad. But again, that's I think, the mentality, the design approach is the problem, not the individual techniques, because each individual technique could be valuable in a well-working design. And you, as long as you come at it from the pragmatic, what makes the code work best perspective, you will discover those techniques when they are appropriate, and you won't use them when they're not, and that is exactly what you want, right? And I think that I don't know. I think that although I'm sure it's a controversial answer for OOP devotees, I hope that's a relatively non-controversial answer from sensible programmers, because again, it's not saying don't ever use thing X. It's just saying the mentality of always use thing X or always think in terms of X is not good. Think in terms of the end result, and then when thing X comes out as, oh, that look at this is solving this problem that I have specifically, I can see it, good, right? And so I hope that is at least, it gives enough flexibility for the individual programmer to approach elements of OOP in a way that they can use the ones that are sensible in the circumstances where they are applicable, and not get saddled with the bad part, right? Which is sort of the dogmatic, I always program everything to look like this, which, I think ignore objects, any kind of dogmatic programming approach that's like the code should always look this way is just probably going to be wrong, right? What are the chances that there's one way to always write code, right? And it's just, it's I certainly couldn't tell you one way to always think about the design of code. I feel like you gotta just always, the one way is to focus on what turned out to be effective, and that's not really a way, it's more of a metric, right? Oh, and I'll just, someone was asking what I think about const correctness. I don't use const anywhere, and the reason for that is I don't really have const bugs. I think on Handmade Hero, we've had maybe like 1 or 2 in, I don't even want to know how many days. 374 episodes. We've had 1 or 2. In my regular programming, I've had 0. So I think mostly the const bugs were ones that I had here because programming on stream, I can't use all my brain. I'm talking all the time, so my programming is worse, pretty much across the board. I noticed that especially in multi-threaded programming too, where things that are hard to think through, I make a lot more mistakes. So given that I don't have any bugs hardly ever, and when I do have them, they're fixed almost immediately, like I don't have the lingering bug problem I don't seem to have for const. That's why I don't use it, because I pretty much know that I never have issues where I modify something I shouldn't be for very long. I just don't tend to have that bug. So that means that all the work of putting const in is just a waste for me. I'm gaining literally nothing from it. However, that doesn't mean that I think other people shouldn't use it. I think basically you should figure this out. Exactly what I just said. How often do you have bugs related to const? Try not using const for a year. How many bugs do you encounter that would have been stopped by having const? Look at those bugs. How hard were they to debug? If they took you 15 minutes to debug and you only had 10 of them in the year, I would say that's a pretty strong argument for not using const. It was hard, it would save you almost nothing, and it's something that you then are saddling all your other programming thought with, right? On the other hand, if you have a const bug every day and some of them take you 3 hours to find, well, that is a pretty good argument for using const in your code, right? So I think it's pretty easy to determine in your particular scenario where you are programming, whatever you're doing, you should be able to figure out pretty easily whether const is something that is making a difference for you or not by straightforward testing. So I would say just do that test, and then you'll know, and then you don't have to ask me or anybody else their opinion of const, because you will know definitively if you should be using it. And people are saying that it's more, on the chat are saying it's more for teams and individual programmers. I think it's the same all around. It's basically the case that you should be able to test this. Your team either does or does not have a problem making these bugs. And what bugs they will make if their const isn't there take variable amounts of time to solve. So basically, do that test. Figure it out. And then you will know for your team, are you wasting your time or not? Right? Because if it turns out your team just doesn't make a lot of bugs like that, then you're kind of just wasting everyone's time by saying that const is better for teams. You don't know that it is, right? You have to actually determine that the bugs that you will introduce by not having const actually take a long time to find. If you're finding that you're just not making that many and they don't take that long to find, it was the wrong trade-off, right? So that's really it. And that's true for all programming paradigms, in my opinion. Every programming paradigm that you're like, should I do this or should I do that? The answer is always the same. Does it make your programming job more, does it make your programming more effective to do it? Then it's a good idea, right? The problem with a lot of them is it's hard to measure. Const is very easy to measure because it has no effect on the code at all, right? Const is just about debugging. So it's very easy to measure. Do it, don't do it, see what the difference is in terms of your debug cost, and then you know, right? You can weigh that against the amount of time you're spending making sure that everything is const correct, and you now know the trade-off. You now know what the right answer is, right? And so if every programming practice were that easy to test, you'd just do it. Unfortunately, it's not, right? Unfortunately, a lot of programming things, it's really hard to do a test about which one's more effective. So I can't give that advice for those. But const, it's really that simple. Are you more effective with it or without it? You should be able to test, right? All right, that's about it. I'm going to wrap it up. All right, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you want to follow along with the series at home, you can always pre-order the game on handmadehero.org, and it comes with the source code so you can follow along with all of the days. We also have a forum site you can go to if you want to ask questions, a Patreon page if you're looking to support our video series, a schedule bot that tells you when we're going to be live, and an episode guide that lets you know when, that helps you follow along with episodes that have already happened so that you can look at them and find what I'm talking about more easily. If you want to know when we will be back next, that is actually tomorrow at 10 a.m. Pacific Standard Time, or Pacific Daylight Time, sorry. It's daylight savings here now, I believe. So I hope to see you back here for that. It seems like we got the kinks worked out of the unproject Z-buffer stuff for the moment. I still am a little worried about the precision. I think we may want to switch to an infinite far clip plane or something. So we maybe will do that tomorrow. But otherwise, what we'll do is play with some of the effects that I wanted to start with today, but didn't have a time to because I wanted to figure out what was going on with some of that projection stuff. So that was good. We got that straightened out. Tomorrow we'll play maybe around the stuff I wanted to play around with today. That's about it. Hope to see you back here for that. Until then, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.